In this video I will show you how to create this sheet metal undercarriage. We're going to be using the sheet metal module in SolidWorks, and notice all of these details that will help us create this sheet metal part correctly. Notice also that those edges are ripped, and that's typical for each corner, and all the other edges are bends. Notice also that each of these dimensions are inside dimensions, to the inside of the sheet metal rather than to the outside edge. In the end, we'll be creating a flat pattern, and we'll create a DXF file of that flat pattern that we could use to send to a laser cutter. And notice also that the material is 5052 H32 aluminum. That's the most common type of aluminum for sheet metal applications, because when we bend it, it won't crack and break. In SolidWorks, the first thing I'll do is choose New and select the part template. And once that's up, I can make sure that I am in IPS units, and I usually like to show 3 decimals of precision when I'm in inch units. And before we forget, let's change the default material from plain carbon steel to aluminum 5052 H32. Okay, now the first thing I'm going to do is on this right plane create a new sketch. We'll go ahead and sketch the general cross section of this undercarriage. We want to capture some symmetry, so I'm going to draw a center line from midpoint to midpoint, and I'll make this center line vertical. I'll also take this line and make them equal in length. Now I've captured some symmetry here. Notice as I drag it in and out, I've captured symmetry. I'll also take this point and put it right on the origin. And let's go ahead and put some dimensions now. This needs to be a 15-inch wide at the bottom and 28-inch wide at the top. It needs to be 13.5 inches tall, and this needs to be 1 inch tall. And we'll finish that sketch, and we can create an extrusion. Now we'll extrude in both directions to a total distance of 95 inches. Now we can create a sketch on this front plane, new sketch, and let's reorient it so that we're looking at that sketch plane straight on. And we'll draw a triangle from here to here, over to here, and up to here. We'll do the same thing here, triangle here. And let's make this length and this length equal so that we have some symmetry. And we'll give this dimension 65 inches. Notice everything's black, we're fully defined, we can finish this sketch. Now let's create an extruded cut. We want to extrude through all in that direction, and we'll choose direction number 2 and go through all in that direction as well. So our sketch is at the mid plane, and we're going one direction through all and also the other direction through all. We choose OK. So now we have that beveled face, but we still need this 3-dimensional beveled face, and there's some interesting complex things going on here. So let's create a new 2-dimensional sketch on that top surface. Orient that straight on, and we'll draw a triangle right here. Now this corner of the triangle needs to be in line with the bottom, so I'm going to change the way I'm viewing this. Instead of viewing it shaded, I'll view it so I can see hidden lines. And this point actually needs to be in line with that hidden line that's representing the bottom of the part. Let's make that in line. We'll take this one and make it in line with this bottom edge. Now you'll notice that I'm underdefined because for some reason I accidentally created just some little stray line here. I'll go ahead and delete that. Now I'm fully defined in this sketch, so I can finish the sketch, and let's create a cut extrude. And I want to extrude downward by 1 inch. And let's change the way we view to see this shaded. So notice I've just clipped that little top corner down to here, but now I need to create another cut extrude that's this sloped 3-dimensional face. I'm going to do that by coming to the sketch and creating not a 2-dimensional sketch, but a 3-dimensional sketch. We'll draw a line from this corner down to this corner, up to this corner, and over to this corner. That sketch is now fully defined, so I can finish it. And I'm going to create a extruded cut of that three-dimensional sketch. Because it's a three-dimensional sketch, I need to specify the direction to extrude. So I'll choose this edge, and it'll, notice it's extruding this way, and I want to go through all, and choose OK. Now I have that sloped face. Now I'm ready to mirror about this front plane, not only this sloped cut extrude, but also this cut extrude. So I'm mirroring these two features, cut extrude 2 and 3. Choose OK. And notice across this side I now have that beveled corner. Now we can do another mirror command. We're going to mirror across this right plane, and we're mirroring, notice what we've selected to mirror. We're actually mirroring the mirror feature. So this feature was mirrored to here, and now we're mirroring that mirror feature across this right plane, and choose OK. So now we have the bevel on all four corners. But you might be saying, hey, but that's not a sheet metal part, that's just one solid part, and that's correct. So now let's go to our sheet metal tab, and if you don't have the sheet metal tab, you just right click here and you can add new toolbar tabs. We have the sheet metal tab already added, so let's go to the sheet metal tab, and one of the tools is to convert a solid to a sheet metal part. So let's use that tool, convert to sheet metal. The first thing that needs to happen is I need to select the base face for the sheet metal. So I'm going to choose this bottom face, and now I can start choosing edges that need to be bent, and it'll try and calculate the ripped edges as well. But actually, before I start choosing bent edges and ripped edges, let's go ahead and specify all the sheet metal parameters to make sure we got it right. We want 1/8 inch thick sheet, we want a 1/16 of an inch bend radius. Let's go ahead and collapse these for a minute. Let's look at the corner defaults. We want a gap for the ripped edges to be 1/1000th of an inch, and the ripped corner overlap needs to be just 0 inches. We don't want any overlap. The K factor is what is used in determining the flat pattern, and when we have sharp bends with a very small radius, the K factor ought to be about 1/3. We'll put 0.333 in. And the bend relief, let's use an oblong bend relief of 50% or 0.5. Now we can go ahead and start selecting some bend edges. We know that this edge right here is a sheet metal bend, so is this edge here. That's a bend. This is a bend. This is also a bend. We know this is a bend, and this is a bend. This is a bend, and these are all bent edges. Now we also know that this edge is bent, and notice when I bend this edge, this one can't possibly be a bend, so it created that as a ripped edge. Notice it's purple rather than pink. This edge also needs to be a bent edge, which creates this edge, purple, which is a ripped edge. This edge needs to be bent, which creates that one automatically a ripped edge with a gap. And this edge needs to be bent, which will create that as a ripped edge. Now I know that this needs to be a bent edge, which will automatically have to rip both of those with a gap. And so we'll do that here as well. Here, and here. Now the next thing I need to do is make sure that the sheet metal is going outward rather than inward, because remember all of the dimensions that were provided us are inside dimensions. So let's zoom in and make sure that the sheet metal is going outward instead of inward from the edges that I've selected. And it looks like, yes it is, it's going outward. Showing this little light yellow, the sheet metal is going outward. If it was going inward instead of outward, I could always go to the sheet metal parameters and reverse the thickness. Now we'll choose OK. Notice what's happened. It's created a sheet metal piece from that big solid piece. And we look in and we say that yes, it did rip the right edges, and we have some bend relief. We can take a look at these edges. We can make sure we have some bend relief down here, and that's just correct. That's exactly how we want it. So this is now our sheet metal part. Now we could find out how much this part weighs by going to the mass properties. We can also find out some information on the flat pattern. Here's a folder. If I click the plus sign there, it shows that I have a flat pattern. I can right click and unsuppress the flat pattern, and it'll show me what this part would look like before it was bent. So I could have a laser cutter, cut this part out, and then I could go to our press brake and bend it. But a laser cutter usually only reads DXF files, and this is a SOLIDWORKS file. So let's go here and we'll do a save as, and we'll save this as a DXF file. And notice it wants to know what I want to save as a DXF file. I could specify the sheet metal and choose OK. And it shows me a preview of what that DXF file will look like. And it looks correct. And when I hit save here, that's a file I could email to a shop that has a laser cutter, and they could cut that flat sheet out, and I could then bend it to the right shape.